3 resistors, 2. Find the following values for this circuit. The voltage drop across R3, R12, the equivalent resistance of resistors 1 and 2, the voltage drop across R1 and R2, the current through R1, current through R2, then the equivalent resistance of the circuit, and finally the battery voltage. So this problem is worked backwards in that the current is given but not the battery voltage. Find the voltage drop across R3. Both the resistance and current are specified for R3. Okay, that's the advantage of labeling these things. And at least this time it was labeled for us. We have current and resistance, so to find voltage it's just Ohm's law, V is equal to IR. Voltage equals 4 volts, and then annotate the diagram right there. Find the equivalent resistance, R12, that's not R12, of R1, here, and R2. They're in parallel, so we use this equation for equivalent resistance. We have 1/2 plus 1/3. We get a least common denominator, which is 6. Add them together, and we get 1 over our equivalent is 5 over 6 ohms. We have to flip that now, or invert it. So our equivalent is 6 ohms over 5, and we call it 1.2 ohms. Next, we redraw our schematic and show the equivalent resistance of 1.2 ohms and the current going through it, which is 1 amp. Now we need the voltage drop across R1 and R2. It's going to be the exact same as the voltage drop across its equivalent resistance. That's the advantage of an equivalent resistance. It will act just the same as the two real resistors. Once again, we use Ohm's law. The voltage is I times R. We have the current going through this equivalent resistance. And of course, it's the exact same current that's going through R3 because they're in series. So we have 1 amp times 1.2 ohms, and we have a 1.2 voltage drop. And we label our diagram. Find the current through R1. Well, that means we have to go back to our original schematic where R1 shows up. So here it is right here. Here's R1. We know the voltage drop because the voltage drop calculated for R12 is also the voltage drop across R1 and R2 individually. So we write that in. There's the voltage. Here's the resistance. To find the current, we use Ohm's law, V over R, and we find the current through R1 is 0.6 volts, 0.6 amps. And we go ahead and label that right there. Calculate the current through R2. Again, the voltage drop calculated for R12 is also the voltage drop across R2. So it's 1.2 volts. We calculate our current by voltage over resistance, and we find that the current is 0.4 amps. Can you see an easier way to do that? Well, once we found that the current through the top was 0.6 amps, we know that the 1 amp coming out of the battery and going through the resistor split, right? So evidently 0.6 went through the top, so how much goes through the bottom? 0.4. It has to add up to 1. And that's what we're talking about here. The two currents, one through each of the parallel resistors, has to add up to the total current going through the circuit. Also, I1 should be greater than I2 since R1 is less than R2. So does that check out? Let's see. I1, you have 0.6 amps, and its resistance is less than R2. So it does have more current. It has 0.6 where the other one has 0.4. So it makes sense. That doesn't prove that it's there, but at least it's a good test to make sure that we're on the right track. Find the equivalent resistance of the circuit. Let's go back to the schematic where the parallel resistors 1 and 2 were replaced by R12. That's this picture here. We now have two resistors in series. We can treat virtual resistors the same as real ones. So to find the equivalent resistance, we just add them. So what do we have? We have 1.2 ohms and 4 ohms. Add the two of them together, you get 5.2, and then we redraw the final circuit just like this. Find the battery voltage. Remember the battery? There's two ways to do it. First, the voltage supplied by the battery must equal the voltage drops in the circuit. So we look at our annotated schematic here. We have 1.2 volt there, 4 here. Add them together, you get 5.2 volts. The second way is to use Ohm's law for the equivalent resistance and the current from the battery. So here we go, we have I and R. V is equal to IR equivalent. Put in 1 amp, 5.2 ohms. We get the exact same voltage drop as the previous slide. Same answer for both. That's good.